This is Accelerated Geometry, Section 7.3, Indirect Measurement using Similar Triangles. Here is a girl standing there, and she would like to know how tall that tree is. She doesn't want to climb the tree with a tape measure to measure it, and so she wonders, can geometry help her figure out the height of that tree? You can use similar triangles to calculate the height of tall objects that you can't reach. This is called indirect measurement. We will look at three methods that you can use to measure tall objects. The first method is the shadow method. If the sun shines down on a flagpole outside, so here's the sun shining on this flagpole, the flagpole casts a shadow, and a right angle is formed between the flagpole and the ground. We're assuming that the flagpole is put in perpendicular to the ground. If you stand outside at the same time, the sun will shine on you and your body will cast a shadow. So here's you, here's your shadow, and another right triangle is formed. So now I have a pair of equal angles. The light rays that create the shadows hit the ground at congruent angles. Assuming you and the flagpole are each perpendicular to the ground, we now have similar triangles by the AA similarity conjecture. So when the sun comes down, this angle here and this angle here are equal. So by these angles being equal and these angles being equal, by AA, we know that those triangles are similar. If they are similar, we can set up a proportion with their sides. So I set up the height of the person over the shadow of the person is equal to the height of the pole over the shadow of the pole. The height of the person is 5 feet. The shadow is 6 feet. The height of the pole we don't know, so I called that H. And the shadow of the pole is 18. Now I'm going to cross multiply. So when I multiply on a diagonal and this diagonal, those multiplications should be equal to each other. So 6 times H should be 5 times 18, which is 90. Then I divide both sides by 6, and I have found out that the flagpole is 15 feet high. I can also measure a tall object using the mirror method. Place a mirror with crosshairs on it. So that means, like, if this is your mirror, go like this. And the center is going to be the point X. So here's the person placing the mirror in between the person and the flagpole. Stand by the mirror and walk backward until you see the top of the object reflected at X on your mirror. At this position, the angle between the ground and the line of sight to the mirror is equal to the angle between the ground and the line from the mirror to the top of the object. So from the ground to the line of sight here, that angle is equal to the ground up to the top of the flagpole, which is this angle. Since you and the tall object are both perpendicular to the ground, I now have two 90-degree angles, so those are equal. So the two triangles formed in the drawing are similar by the AA similarity conjecture. If they are similar, I can now set up a proportion, a ratio of their sides. So I said the height of the person over the distance of the person to the mirror is equal to the height of the pole over the distance from the pole to the mirror. The height of the person is 5. The distance from the person to the mirror is 3. The height of the pole I don't know. The distance from the pole to the mirror is 9. Cross multiply, I get 3H is equal to 5 times 9, which is 45. Divide by 3 on both sides, and I get the height of that flagpole is 15 feet. This is another method. It doesn't really have a name. What triangles in the picture below are similar and why? So this is what happens. Here's a tree, and the tree is that tall. The person walks until you can draw a line from the top of the tree to the top of the person to the ground. Okay, you assume that this person is standing perpendicular to the ground and that the tree is perpendicular to the ground. So those are two 90-degree angles that they share. And look, in the smaller triangle here, I have an angle A. In the bigger triangle, CAD, I have angle A. So angle A is in both of those triangles. So therefore, by AA, the two triangles are similar to each other. So AEB is similar to triangle ADC. What proportion would you set up to find the height of the tree? So we set up the girl's height over the girl's distance from A equals the tree's height over the tree's distance from A. So this height over her distance from A and the tree's height over that same corresponding side in the triangle, the tree's distance from A. Now I fill in my numbers, or my letters. EB over AE is equal to DC over AD. So 1.82 over 6.10 is equal to the height of the tree that we don't know over this total distance, which is 6.10 plus 12.20. So I add these together and get 18.30. Now cross multiply. 6.10 is equal to these two multiplied, which is 33.306. Divide by 6.10, and I have an answer of 5.46 meters. There's also a good video on MyCMH Luke's Chapter 7 for Section 7.3. So if you're interested in seeing some of the more problems like this done, check out that video. Now you have enough information to be able to do your homework.